Hello, welcome back to my channel. I'm excited to continue from where we start. So, in this series of C Sharp and object-oriented programming using C Sharp. So earlier on, I've been, previous videos I've been teaching you guys the basics of C Sharp. We learned stuff like just basic syntax, the outputs from users, input from users, comments, variable, data type, typecasting, operators, and the if-else statement, and then the switch case statements as well. So right now, I'm going to continue from here, and we're going to start learning from loops, iterations, and loops. This is a very important concept in programming. In fact, one of the most key concepts in programming. So I'll try my best to make the explanation as easy and as simple as possible, because sometimes programming could be pretty confusing, and hopefully I can try to make it as easy and as simple as possible while trying to deliver good content and good quality out there. So let's start. What is loops? So loop. So basically, a loop can execute a block of code as long as a condition is reached or the condition is met. So for example, this is the syntax right here. I'm going to just copy and paste it right there. So this is the condition, and this is a while loop, right? So as long as this condition is met, this code will keep executing. It is just keep executing as long as, until this condition is met. Sorry, for while loop, until this condition is met, it's going to keep executing. So the word while, so it's like saying while this condition is true, keep doing what is in this code block. Just keep doing that. Keep doing it, keep doing it, keep doing it. So that is while loop. There are two major loops that we have. We have the while loop and we have the for loop. So these are the two major loops that we have. The rest of the other loops are just a kind of branch of these loops. So for example, there is something called do while loop. So it's just more like a branch of while loop. So if you understand while loop, the do while loop is basically the same thing. It's just the do and the while. And then the for loop. So these are the major loops that we have. And then I'm talking about the while loop right now. So this is the condition. So let's try something out and continue with the while loop. Okay. So I'm going to try to use something I've used before, just so we're familiar. Counter. I'm going to try to increment the counter every time we're in the loop. So the counter will be incrementing every time we are in the loop. So we're going to do int count equals to 0. Let's put it 0 right now. Okay. So we're going to say while this loop is less than 5, as long as this loop is less than 5, keep counting, keep coming into this loop. So less than 5. Remember this operator symbols that we did in the previous sections that we worked with. So this is like the operator, right? Is less. So while the counter is less than let's say 5. Okay. So while this counter is less than 5, as long as it's less than, so right now the counter is 0. So that means it's going to come here. Actually, so I think we need to do something like this, right? So while this counter is less than 5, so counter plus, increment the counter, but before that, let's just print out something. So dot right line. We want to print out the counter number, and then just show it on the screen. Read line. Console read line. Okay. So the key thing here is the while loop. The while loop, because while this, so it's like while, it's just imagine English word while this counter is still less than 5, keep print the value on the console, and then increment the value by 1. So remember the last episode we learned this plus means increment the value by 1. So just add 1 to this. So it's going to come to the loop again and ask the question, is it less than 5? Yes, it is 1. 1 is less. It's going to come here again and do this until it is equal to 4. Until this value is equal to 4, because 4 is less than. And then it's going to print. Then it's a 5. Once this value is 5, it will stop printing. So at that point, this loop will stop. So let's run this and just see the result that we printed here, and then we could make more talk more about it. The result printed is 0, so the counter is that. Let's see why. Let's run through here so we can debug and see what's going on. So we're saying that is that. Comes here again, but this value is that. The value is 1 now. It shows now that value is 1. When I press enter again, it's going to increment that value to 2. So if you look at this place here, you're going to see this going to 2. And then you keep going and enter again. This will increment it to that's 3. Let's go again. This is now 4. And if we look at this whole thing here, printed 0, 1, 2, 3, 4. So now it is equal to 5, and 5 is not less than 5 is equal to 5, right? So it's not less, so it's not going to come in here anymore. It will get out of the loop. So that's the while loop. While is less than 5, but 5 now is not less than 5. 5 is actually equal to 5, so it's not going to come in here. It will stop the whole code. So this is while loop, right? So that's the while loop, and that's how it's going. So now let's look at for loop. What are we going to do for loop? Remember I told you there's do while loop as well. So the do while loop is very similar to the while loop. If you know how to do while loop, do while loop is very similar. Do while loop is just, you're just going to, this here is going to be the do, here is going to be the do, and this is going to be the while, and the condition is going to be the while. So it's like do, and the condition here is going to be the while. So this thing is kind of letting us, like, it's helping us to do it. Right? So it's the same thing. it's just like the do while loop is like the action is being executed first, and then while the counter, like while the condition is being met. So the difference between the do while and the do while loop is that the condition here is being met first, and then it's going to check it. The code is executes one first. Pardon me. The code executes once first, then it's going to check the condition for a while loop, and then it's going to keep executing if this condition is not met. Yeah, until the condition is met, it's going to stop. So this is like the do while loop. The do while loop. So that's that. Okay, let's continue with the for loop. I just want to mention the do while loop. So let me go back to how it was before. While loop. Okay. So let's do the for loop, right? Let's do the for loop. So for loop, if you type this actually in your Visual Studio, type this, just type 4, and if you hit the tab to see your tab key, hit it twice, 2 times, fast, like that. It's going to generate the syntax for loop. I know the syntax of for loop sometimes can be, if you're not a seasoned programmer or not well experienced, sometimes the for loop syntax can get you confused. But if you hit type 4 and hit the tab key twice, it will generate this syntax for you. Basically, this syntax is like your variable, like the first variable, and you set it. So if you set it to whatever you set it to, this is set to 0. That means initially your I variable will be 0. And by the way, this I, you could name this I to be anything. It could be my integer, my int equals 0. But if you name it as my int equals 0, make sure it changes. Yeah, so you see it changes all these guys, right? So make sure that is info. The common thing is just to leave it as I, I meaning index is a short form of index, right? So the initial I, which is this guy, this one's the initial one, you can set it to any number. If you set it to 1, your for loop will be starting from 1. If you set it to 10, this for loop will be starting from 10, and then this one is an increment. So every time it loops, every time this for loops executes, it will come back again and check the length of your data. So there's a data somewhere, right? So let's say there's some data somewhere. Well, let's say there's some data somewhere. Well, this will be more clearer when we do arrays. So we can use arrays to actually explain the for loop very well. Okay, so for now, just assume there's a data somewhere. The length of that data, as long as that length is less, the I value is less than the length of that data, you keep executing until you increment this guy, until this I value is now less than this length. Okay, I mean until this I value is now greater than the length, then you can now stop, right? Okay, so all right, so that's that. So let's go on to arrays, because this I need to explain the for loop, and I need to explain the for loop with arrays. And yeah, let me just take a screenshot of this guy, just so I can know I've covered this. All the ones that I covered, I just take a screenshot of them, just so I know I've covered them. Alright, so let's go to arrays now. Okay, so I'm going to take off this this loop thingy. I still want to put the for loop because I need to explain the for loop with arrays. That way you can understand better what the for loop is all about and what is an array. Also, you can understand better from there. It's much better with for loop using an array. Okay? Using just regular integer equals to 5 or something will not explain this better. So let's dive into what an array is. Okay, and I'm going to be changing this to array. Yeah, just so we know, it reminds us what we are up to. Yeah. So arrays. What's an array? So arrays are used to store multiple values in a single variable, right? Instead of declaring separate variables to each value, you store multiple variables that looks similar data type in one array. So in a bit you're going to understand. So the syntax for an array is using the rectangle, the square braces. It's your parameter name and your square brace, your data type and your square braces, and then your parameter name, your variable name. Sorry, your variable name, your data type, square braces, your variable name. So this is, for example, this is a string array. So when you do this, you put the rectangular braces and you type, like, let's say for example, cars, right? Cars. So this is an array. This is a string arrays of cars, right? And an array has fixed length. So once you declare an array and you say that the array is, for example, you say the array is of array equal to array number, array 5, assuming, so right? You cannot change this thing now to say, okay, the array should be an array of 6 elements or 7 elements. It's always going to be 5 elements in this array, so it's a fixed length, right? Now to initialize your array, right? To let your array have values. Right now we just declare the array. We have not initialized this array. Now let's go ahead and initialize this array so that we can use it, so that you can understand what I mean by array. So basically all you need to do, so you can see that C# is already trying to help us. So just curly braces, open and close, curly braces, like that, comma. Then inside of here, remember it's a string of arrays. Array means it's multiple values, right? Multiple values. So it's a string, multiple string values. So let's do the first car is Toyota, right? And you put your comma, right? And you go under, you get again another comma here. You can do just put a string first, BNW, and then you can do another one. Let's say we get let's do like 5 of these guys, or let's do 4, right? Let's do 4. Let's say 4. Okay, so we have car arrays. So this is an array right here. This is the syntax of an array, right? We have a string array with 4 string values, like 4. The length is 4, right? The length of this array is 4. Now once we declare it as 4, we cannot change it to be something else. So this is 4, and then this is where we can now use for loop. Okay, so now I'm going to uncomment this guy. So to read the value of this array, you could either read the value by just doing cars the index, the array, another thing is the array always starts with the index of 0. So this guy here is Toyota is 0, Honda is 1, BMW is 2, and Volvo is 3. So to get the value of the first one is put the index of 0, and then that's it. This will be so this here is this will get you the first index, which is this guy, and likewise if you want the second index you could do like that. That will get you that Honda. If you want the third index, that will get you that. Just to prove this, I'm going to try to console dot read line and dot write line and then console dot read. Okay, let's just comment this guy out first. Let's just see that this is array number 0, 1, 2, 3. So this is Volvo, the 3. It's going to print out Volvo. So let's see if that is the case. Yes, it prints out Volvo. So from this array, we're able to get the third index, which is 0, 1, 2, 3, which is Volvo. Remember, array starts from index of 0. Everything, even if it is the first one, but it is not actually starting from 1, it's starting from 0, 1, 2, 3. So if you put 3 here, that means you print out the fourth content in the array. So that's that. Okay, I just wanted to show you that that is how you can actually read from the value from the array. Okay, so that's that. Let's comment this out for now while we do our for loop. Okay, so remember I told you that the length, so this is the start index is 0, so the initial index of this loop should start from I equals to 0. So the initial index is this one here, 0. But the conditional, this is the condition of the loop. You're saying that as long as this I here is less than the count of the length of this guy, then continue doing what is in this loop. But after you do that, you have to increment I. So right now, remember, right now I is 0, and you're saying that as long as it's less than the length. Right now we know that if we supply this guy as the length here, we know that this has 0, 1, 2, 3. We know that it has four things inside of it. So this will come and increment this guy, plus increment the 1. This will be 1. It will come again, increment it, this will be 2. It will come again, increment this will be 3. And then it will increment it until this guy, which is I, this value here, which is initially was 0, will increment until this value would be greater than the length of this guy, or no, equal to the length of this guy, and then it will come out of the loop. So for example, now that we have an array that has 4 items instead of 8, so we're going to do the array dot length okay. So array, the cars array is dot length, and we know that the length of this array now, it has 4 items instead of 8, so it is obviously greater than 0. And we're saying that the only condition for this loop to stop looping is if the length is now less than I. Right now I is 0, the length is 4, right? So 0, it will come, 1, it will come, 2, it will come, 3, it will come in here. So that is the loop condition, right? And then let's just do this guy here. And I'm going to show you one more important concept about for loop and about getting values in the array. So you know how when we got the value directly from this by passing this number 3, we just got the value directly now. Now it's not like we can't do that anymore. We can't just get the value directly like that. We can get the value now using the I index here. So my car now here, if I have to use the same variable, my car cannot be 3 now. It cannot just be 3 now. It has to be cars dot the value of I, that's iteration. It could be 0. I is equal to 0, right? But every time it loops here, we want to get the value of I and print it out. Every time it loops, you get the value of I. So right now it is 0, so it's going to print out Toyota. Then when this increases to +1, this value of I now will be 1, and it will print this guy. It's going to loop again. This guy increases the value of I, so this will be 2. So it's going to print out the index at 2, this guy, like that, like that, like that. So this is how, you know, we can do the loop, right? And get the value of an array from loop. Okay, so this is for loop, and let's go ahead and run this again just to make sure that it prints out everything as it should, and then we can go from there. So it prints the first one. We need to go for the second loop. Print the second one. We need to go to the third one. Print the third one. We need to go to the fourth one. Print the fourth one, and then it's going to stop right now. Watch, everything stops. Well, let's not just do that. Let's put a breakpoint and see how it's actually coming here to print, just so we know. Okay, we're here, and I at this point, look at this. Look here, look below here. You know, I is equal to 0, right? So it's going to put 0 here. Remember, when we had the number 3, it printed this guy. Now the number is 0, so we're expecting to print this guy. I at this point is equal to 0, so it's going to come in here. In there, I at this point is equal to 0, so we are going to get the car at the 0 index. Look at that, it has Toyota as the car as the 0 index. So the rest of this is just printing, right? You know, right? So we get that, and I need to, how do I make it to come down back here? Excuse me. Well, it just keeps looping through and just printing them out through like that. I just want to show you that syntax. Alright? So we're stopping it. Okay. Alright. Now I want to show you something very cool and very quickly. So for loop has this like this looks a little bit complicated for someone that is not too strong at programming. But this is the basics anyways, but it still looks complicated. But there's another version of for loop that is shorter. It's for loop, but it's shorter. So it is called, so if you type this, if you look down here, you're going to see something called for each. For each, this one here, for each. It is the same thing as a for loop, but it is shorter, and it's shorter than the for loop. Right? So if you look down here on this code snippet, tap twice, and start the for each snippet. So if you tap twice, hit tap key 2 times, it's going to insert it. So hit it 2 times. So you insert it like that. Well, with the for loop, there is no i's. You don't see the I index or something like the I plus plus and all those things. So it's a little shorter and cleaner. So what you just need to do this cars, and then just name this variable something else. So you just remove the S there. So you have car right there. And at this point, all you need to do is just print. You don't have to do you don't have to try to get the I index. You don't have to do this line here, right? All you gotta do is just print that value. right there, and you're good. You're as good as, you know, that's it. You're good. So let's comment this guy out and let's run this code again. It's going to be the same thing as the for loop. It will be the same thing, but look at how short this code is right here. So the for each is a lot shorter and cleaner, right? So let's run this again just to show you that it's the same thing. You see, we have Toyota. If I keep going under BMW, Volvo, and then code exit. So it's the same thing as the for loop, but just a shorter version of the for loop. Alright, so it's good to show you about arrays, and it's also good to show you about for loop and for each loop. I hope you can take this time out to pause the video and do a little bit of practice and try to understand these concepts very well. The more you work on the code, the more you get to understand. Please continue watching my video to the end, and please subscribe to this channel. I really appreciate your subscriptions, and I really appreciate your likes, because the more you like the video, the more YouTube is going to suggest my video to other people, and the more you subscribe, the more my video is going to get to more people. So thank you very much, and please subscribe to the video. Alright, so now the next, okay, I'm going to take a screenshot of this real quick. The next thing I want to do is, now I want to get into some of the real things. All this while, what I've been doing is just trying to teach you the concepts of programming. So now let's go to what, like, methods. What methods are, what parameters are, or methods, what classes are, and all this kind of stuff, good stuff, right? Alright, let me just save this one first, then we can go from there while we are at it. Okay. Alright, so I will be Alright, let's do methods. Okay, for this guy, I'll have to delete everything, so we can start fresh. Start from the scratch. Clean slate. Alright. Now just understand what method is. A method is a block of code which only runs when it's being called, So if the method is not called, it will never run. Just so you know that, right? You can pass some data into the method, which is known as parameters, into the method. Methods are used to perform some certain actions, and they're also known as functions. We write methods so we can reuse the code, use it many times, as many times as possible. Excuse me, let me just drink some water. So a method is created, the syntax is the method name, and then followed by the parentheses, and then followed by if there's parameters, if there are like parameters to pass in parameters. Okay. Alright, so let's start with our first method. And this method or function, remember, functions are things that actually do things. They take action, they do things, they work for you, and all of that. Let's say this method will what can we do? So this method takes in lowercase word and then converts it to uppercase, right? So let's say void to convert to uppercase. Alright, so this method will convert to anything we give to read. So it's going to take a string as a parameter. Lowercase. It's going to take a string as a parameter and then open and close parentheses, and then we're going to convert this to uppercase, right? And then so this is going to be a function. Every time a word is in lowercase, convert it to uppercase. You can see how useful this method could be. Sometimes you need to your website, you need to make sure that the header is always at uppercase, so you can call this method to always convert whatever word it's going to be header to the uppercase. See how useful this can be, right? Okay. First of all, I need to explain the syntax of this method to you. This right here is called the return type. The return type in this case is void, right? Void means it will not return anything back. Okay? If you want something to get returned, it has a return type. Sometimes you want an integer to be returned. So let's say you're creating a plus b, you're creating an addition, or you're creating something that is going to return you some value, number value. This here will be integer. So when you call this method, wherever you call it, the results that will be coming out of this method will be an integer, if that is an integer. But if it's a void, there is no return type. So you don't expect anything to be returned back from, like this, expect any value to be coming out of this. You just know that this method will just do something like this and just end here, right? Sometimes if you're going to save something to database, sometimes you don't need some result back, because to save into database, you just use void. But in this case, it looks like we will have something to be returned back to us, because when we pass in the lowercase word, we want it to convert it to uppercase, so that we can print it out. Oh, look at it, it's uppercase. So in this case, we will have to use a string. So it should return us a string. It should return back to us a string, and so the moment you could see, once I change this back to string return type, this method is complaining. It has a red line here. It's telling us that this code needs to be returning something. Like if you look at it, it says not all code parts return a value, so it needs us to return a value back. So for now, we could just do string dot to uppercase dot to upper, right? So we are converting this lowercase now to upper. This to upper is a C# special it's a special method, extended extension method in C# that we could just use. It has C# has an extended method called to upper. So we're just converting this lowercase dot to upper, and it will convert that and assign the value to here. And then still this guy is complaining, so you're going to see your first return statement. So you're going to do return, and then you return this uppercase now. So now this method has the uppercase being returned. So you can see that the error is gone. So now we're going to call this method in the main void here, the main method. This is the entry point of this code. So we're going to call this, I'm going to create var results is equals to convert Okay, guys, needs to be static. Well, it's going to complain because we don't have this yet, but in a short while we're going to have it. So because we're going to do console, the user will input that value, console.writeLine, and then we're going to tell the user to write, please enter the word in lowercase. Okay, so right now we're going to read the value as, I'm going to call it lower because that's what I want to use it for. Also the read line. So now you see that we have the value right there. It's going to be passing that, right? So we enter the lower value right here, and then so now I'm going to print. I'm going to print it. I'm going to print the value. When we get the value, we're going to print the value, right, so that we see it. Also the right line. And then also the read line. Read line. Okay, so let's see how this works. I will let it hit here first, so we're gonna see how it's working. So this is how to call a method. You write the method and then you call it in a different function. So please, it says please enter the word in lowercase. So I'm going to say thank you in lowercase, right? The word thank you all in lowercase. And I'm going to enter. Okay, so we're here. We got the lowercase thank you. And we're going to go into the method. Now, for the first time, I'm using this now. This here is stepping into the method. Remember, all along I've been using this one, which is step over. So you step over the line, step over the line. But now I'm using stepping into means you are stepping into that line. And in this case, the line is this method. So we're stepping into the method. Now you see how we're calling that guy? And then we're converting it now to uppercase. Look at this now, it converts it to uppercase. Thank you. Right? And then we return it. Now it's going to return. It will return the value to this variable here. Thank you. And then the rest you already know. It's just printing it and reading out. So console.writeLine will print it out. Console.readLine will just read the printed value on the screen. I think I closed it. Oh, right there. So you see, so we entered thank you, and it printed out thank you in capital letter. You could see how useful methods can be, and then a method like this can be very useful when you're writing in multiple lines of code, and sometimes it just needs a method that could just perform a task, perform a particular task for you while you're writing this thing. In this case, it was very useful. I wanted something that will convert anything that is lower letter to upper letter. For example, I can give you an example. When you're developing a website, some of your header, your keywords or the headers of your website, you want them to always be capitalized, right? Capitalized. But not every time you can guarantee that the values that are coming into that upper headers and all of that are capitalized. But this method could always help you to check and make sure that all of them are capitalized. So this is a method, and yeah, this is how it is done. Earlier on, this static, I added static here because if you look at this main void, I'm trying to call this method inside the main void, and this main void is static. So therefore, any other method that is being called in here won't have to be static. So that's why I put the word static in front of it, just so you know that. Okay, so that is methods, and now this method is parameterized, right? So when you pass in a value or you pass in something to work with in the inside a method, it's called a parameter. This is a parameterized method. There could be other methods that don't have parameters at all, and they still work as methods. For example, we could have a method like add. Okay, so we could have like static integer as a return type, add, because now it's going to be addition, right? So we're going to return add. So I'm going to say int number one. No, we have to put together. Number one, and then no, we don't even need this for now, because I'm trying to teach you the ones that don't have parameter, right? There are certain methods that don't need parameter at all, so we don't even need that for now. I'm going to show you that we don't need it. So if I do int a equals to 5, int b equals to 10, and then we're going to return a plus b. So a plus b will be 15, right? A plus b, return a plus b. Now this is an integer. Both of them are integers, so when they return, they're going to be integers, right? So if we go ahead and just call this guy here, assuming that we just call okay, let's just call it here. Right there, below there, and then that's it. That's all you need. And let's just make sure we put this one out. Yeah. And I just comment this out for now. Okay, so I will not put a breakpoint. This is just to show you that we could write a method that does not have a parameter. So this is parameterless method, and this is parameterized. The top one is parameterized method. A method can have many parameters, multiple parameters. A method can have 0 parameters. A method can have 1 parameter. So it's up to you, the use case you're trying to use it for. But let's make sure that this one here works. You should print out on the screen 15. Right, there you go. So you print out 15 on the screen right there. So that works very well. It's parameterless method. All we need in the method is supplied within the method, and then we can use it to calculate the rest of the values. So that's that. Actually, this is all for methods, and I want to go to a different concept called method overloading. Okay, so now we are getting into a little bit more into methods, a little bit more into stuff. While we are on methods, I'd like to do the method overloading so that we could understand what that is and go from there. So let's copy this guy as usual, save it. Okay, so this is, I am going to leave one of these guys here. Okay, first of all, let's delete all these guys first. And now we're discussing about method overloading. So what is method overloading? Method overloading is a process where a method can have multiple different parameters. The same name of method can have multiple different parameters, and it can have different orders of parameter, and you can have a different return type, but it's the same method, right? Take for example, if you are developing an application and they tell you to get the users, okay, you could actually get user with no parameter. You could get a user with no parameter. You could also get a user with parameter, and you could also get user with a parameter of like a parameter and using a different kind of parameter. Let's say you got the user with an ID, okay, you could also get a user with name. So it's two different parameters, right? But you're getting a user, or you could get a users without any parameter, right? I don't know if that makes any sense, but yeah, so that's like method overloading, as it would be. I'm trying to think of a good example that I can use for method overloading that doesn't require too much of coding. Okay, so how about we try to do this and see if it will work. Okay, I'm going to write a method that returns the same name. It's going to be addition, right? It's going to be addition, but one of them returns an integer and takes in integer, and the other one returns a double and takes in doubles. Okay, so let's do the first one. I'm going to call it addition. We're just going to call it addition. It's going to be the same method name but different parameters and different return type, right? The same method, but it's just going to take. So let's, without wasting much time, let's just start so that you understand what I'm talking about. Static int addition. This one will take x, int a, int b, right? Does that make sense? So now return a and a plus b. So same method name, it's just a return type, so I'm just going to copy this guy over here, right? Same method. You look at it, the same method. It's complaining right now because it's the same method name and the parameters is the same, the return type is the same. If you change the return type to double, it is still complaining right now because you cannot return, like these guys are integer and they're not of the same type. If you change these guys to double, it's good now. But look at these methods name are the same. They are very much the same. Look at them, they're the same. So if you come in here and try to call this guy over here, like try to call it like we usually call methods, you're going to see in here, this is where you know that method is overloaded. It has one of two. That means there are two addition methods in this class. So its method, the method is overloaded just by the name. The first one returns a double and takes in a double. If I use this arrow and go down, the second one is returns an integer. This return type is this one on the side and takes in integer. So this is method overloading. Method overloading is a very important concept in C# and in programming, even in Java too. The same thing in Java as well. Most of these things I'm teaching you here is applicable to Java as well. So that is method overloading, right? So which one do you want to call first? I want to call this var method int. Okay, so this is method the int one. Assuming we're calling the method the int one. So what we need to pass is 5 and 5. So you see that the moment I pass 5 and 5, it knows that it's the integer one that I'm calling, and it's just gonna fix itself. So let's call the other one. Oh wow, this knows exactly, but it's still calling the integer one, so we need to change it to maybe 5.1 and 5.4. So when we do this now, you see that it's a change to the double one, right? Double, this one is integer. So it knows. So this is what is called method overloading. Alright? So it's an important concept. I just want to point that out for you. So I'm not going to print this out. I'm just going to leave it like this because we'll be printing out, and this is correct. This is the two methods here, and you can have many different methods with the same name, but this is just that. Alright. Okay, one more concept that I want to teach you guys before we go to the principles of object-oriented programming, is access modifiers, right? Access modifiers. But before we go into that, let me copy this guy. Okay, from now on, the rest of the video is going to be real details of programming. So we're going a step further from after this now, the actual programming now. Once I do the access modifiers, it's going to be the real programming. So I'm going to start to create classes, I'm going to start to create methods and classes and all of that. So let's take our time here. If you need to pause the video and revise on what you've done so far, go ahead and pause the video. I'm kind of taking this step further. I'm just hoping that I don't get to lose anybody in terms of understanding this. Let's just make sure that everybody's following the video. Okay. Alright, so let's continue. Okay. Next one is access modifiers. So access modifiers is a very, very, very important topic in C# or any programming languages itself. So access modifiers is what allows you or allows us to have access to these methods or this class or properties and fields and all of that. The basic access modifier, the default access modifier is, for some programming language, is public or private. Okay, so the first two that you will actually get to know about is the public or private access modifiers. Right? To explain access modifiers, I'm going to be needing a new class, to create a new class. That way we could actually know how these access modifiers are working, and we could go from there. But I want to explain the very basic two that you'll be using most of the times. And again, let's delete all these guys because we need to start from a fresh slate. Very fresh slate. Okay, hold on for a second. I just wanted to explain these guys one after the order. I still got here. Okay. Alright, so the first one is public. The public access modifier means that the code is accessible for all the classes. By the way, access modifiers are the first thing that comes in front of any class or any method or any property. So this guy here is access modifier. Look at it here. The last one here is an internal access modifier. So all the previous methods that were written here, I didn't specify any access modifier because I'm writing it within this class. They are within the class, so you don't necessarily need to put any access modifier, public, private, or protected, or internal. But once you create a class and you have a method in that class or a property in that class, you would need to put access modifier, most preferably public, because public means it is accessible all over for every class, everywhere. So the code accessible for all classes. So basically what this means is everywhere in this project or in this tutorial I can access any method or any class or any property that I assign as public. Well, private is the opposite. Private, the code is only accessible within the same class. So if I create the method in this class and I declare it as private, it can be accessed only in this class, only right here, or in a different class you cannot. Protected, the code is accessed within the same class or a class that inherits from that class. We have not taught inheritance yet, so the word inherit here might be a little bit strange, but just know the definition, okay? Internal, the code is only accessed within its own assembly, but not from another assembly. Well, you're going to learn more about assembly and all these things. But for now, let us work with these two first. But these are the most common ones, right? The most common ones you see a lot is public and private. So let's work with these two. For that to happen, I'm going to show you an example with a class. Let's add a new class. I know the very first video that I did, introduction, I taught you guys how to use classes or how to create classes. So let's just do math class. Okay, so just do math. This is going to be addition and subtraction and all of that. I'm going to change this from internal to public. Alright. Okay. And I also want to change. No, I'm not going to change anything. I will just probably just do property user ID. Alright. I just want to see if we could show you that some of these things you could see them and some of them you cannot. Integer employee ID. Let's see if it keeps telling me what to do. Username. Okay, let's see. Then I just add one more. Well, the username cannot be integer. Remember, username is like you have like a username like email or special username you create. It has to be a string or a text, which is a string in C#. So string. Okay. So as you can see, all of these are public. The class is also a public. The class is a math class. I'm going to add a method in this class that is going to be of public. Double amount plus, I guess I'll just call it like that, amount plus. It's not going to take any parameter, so we're going to return 5.2 plus 5.3. Okay, so these are the methods, right? This is the method and these are the properties. Remember, for my first object, for my first calculation, my first tutorial, the properties are features of a class. Right now, these features does not even match the name of this class. It's a math class and it has all these things. I'll just throw them in there just so you can see what they are. Because of the example that. So looking at it very well, let's change this guy though. It needs to match, right? So let's change it to user class, so that you need to kind of create classes that match users, right? Okay, so this is user now, right? So you can see that right now is user ID matches employee ID. Well, it's kind of match, and then username would match a username, and then password would match a password. Amount plus does not necessarily match, but this is just for me to explain what this is. So all of them are public right now. So now we'll go to this class now. We'll come out now in a different class, and we try to make a call to this guy, to user class. My user equals to new user. Remember when I told you guys that once you create a new, keyword new, that means you've created an object of that user class. You could have multiple objects. You could do user 1, user 2, user 3. That means you've created 3 users, right? But we don't have to create that. What I want to show you now is, watch if we can access all of those properties, because right now they are public. So you will see that user, you can see username, user ID, username, employee ID, amount plus, and employee. Is it? I thought I had like 3 of them. I thought I had like 4. And password. Where's my password? Look at it here. Like employee ID, password, user ID, and username. And then also amount plus is right here. So we could see all of them. You could access all of them because right now they're all public. Well, let's go make some of them private. As a matter of fact, let's just make all of them private. Just click on the user ID. So all of them are private. We have only user ID as public. Now you could see if we can access any of them right now, or all of them. Let's see. My user dot. We can only see the user ID. You can see only the user ID. That's what you can see. The rest of them are not there. You can't see them. User ID only. Why? Because the rest of them are private. So private, you can only access private in that class, in the class that you created it for. That's the only place you can access private. Like if you could see this guy here, right here, right? This is showing you that you can only access that guy from the class that you created it in. So that's why you see only that guy. Right, so that's why you see only that. Let's see, give that to that. Right, so that's that, and that's some of the access modifiers. They always in the front of the method or the class that you're creating. As example, this guy here, public class user, public int, private employee. Now, because these are private, they cannot be used elsewhere. It has to be used in this class. It always only has to be used in this class. All the private ones cannot be used outside of this class. So that is that. Right. Okay. Another thing is, let's say this class is private. cannot see this class. If you make it private, you can see this class outside of this. Like basically, I don't think. Let's see. Like, okay, so this class is complaining. Elements defined in the namespace could not be explicitly defined as private protected. Okay, so this one cannot do that. Okay, plus that. Wait, you could do sealed, right? Sealed. Right. So if you do sealed now, it cannot be inherited. So you could see it. Okay, so let's leave it like this, and that's it on access modifiers. I hope I was able to teach you guys access modifiers in a better way. Okay, let's copy this one. So my next topic now is classes and objects. It's more like the first tutorial that I gave on this series, the very first one, Introduction to Object-Oriented Programming. That was the first thing that I did, and let's just go over that again just to make sure that we're actually following up or try to understand what classes and objects are. I think we've already covered most of that again, but let's just do a revision again just to get you to understand better. So classes, objects. Alright, so like I said previously, what's a class? A class is a blueprint of an object. Okay, so what is an object then? I mean, like I say, what a class is a blueprint of an object. What is an object? Well, to make you really understand an object, think about an object as anything that has a feature, that has features. It could be a laptop, it could be your table, it could be your computer, it could be a person, it could be a car, it could be fruits or a fruit. It could be anything that has feature. What I mean feature, anything that has something you could describe about. Can you describe a laptop? Yes, you can describe a laptop. How many, the screen size of the laptop, what is the memory of the laptop, the hard disk drive or the hard disk space of the laptop. All of those things are described in the laptop, and all of those things are features of the laptop, right? When I mention the features, I mean they are the properties of that laptop, right? So we already had a class created from our last video. That will save us a lot of time. So basically, I'm going to go to the user class and create a class right here. To create a class, you just right click here, you come over here, class right there, click on it, give it a name, and just click enter. In this case, we created a user class. Okay. If I told you that a class is more like a blueprint of an object, and an object is anything that has anything that you can describe, anything that's basically, you could describe a laptop, right? You could describe a bottle, you could describe a car. So anything you can describe, anything that has features, you can describe it. So a user, when you have a user onto your website, you have a website and it's a user. What are the features of that user? The user is going to usually have a username, right? A user is usually going to have a password, and the user. So for now, let's move this employee ID. That was just for demo purposes. Okay, so user will have a user ID, we have a username, and we have a password. So these are the features of a user, right? So these guys are in this place. Now we could do, let's change this method again to, because we don't, that was a previous string, get username, get user. So let's just say get user, right? We'll just leave it like that, and let's just say this returns the user is so let's just do get username for now, right? Let's just get username, right? Let's do that, and this is going to return us the username as so we're going to pass in a username and then we're going to return it. Anything you pass in here is going to return it as a username, right? Let's do that. So let's have a method in here that returns a username for some reason. Just returns the username. And we'll be setting this username. Just for simplicity's sake, let's just return this method. So looking at this now, this class is specially building a user, right? So this is building a user, and if you create an object of this class, you will be returning an object of a user, and then it also has a method get user. From our last class, we actually made these guys private, so let's make them public back so we could have them available. Alright, so we created this class, and we have objects, we have properties of this class, and the properties are the fields or the attributes that describe the user, right? Those are the properties. And then we have a method that can actually return us a user name, a username, right here. Now, to get a feel of this class, we have to come to this place and create an object of the class. So when we create this object of this class, you're basically now assigning a value to that object. So you're saying the user ID is equal to 92983. So what is the password? My user dot password dot username is this, just say demo user. Okay, so that's the username, and then you come here, you do my user the password is equals to password. Let's give the password as IA at PE221. Okay, that's that. And now you have the user created. So you create an object and you assign values to this object that you created. So this right here is a class that you create. It has the properties, and then you have to now use these properties and do something. Assign them, give them values for you to do that, you have to create an object. This right here is the object. Anytime you do a new class name, this is the object. This is what qualifies to be an object. This is the object instance or the object variable. So once you create the object, this instance is what you'll be using from that point on, and this instance will expose all the properties in that class. Now you can use that to do anything. So for example, we could also do my user dot the method name. Remember the method get user? It's still there too. We have the method name, and then we can assign anything in here. Assuming we're going to pass in a string of username of, let's say, new username. Right, you pass in that string. Now you have access to all your methods right there. You could also as well create another user again, second user. So you could create as much users as you want, just because you have created a class. Now this is the second user, or let's say second user, and then you could give it another user ID right here like this. So because it's a different user, we have to change the user ID to 331 like that. Then we'll use a 2, and then change this demo that to a different number, and we change this guy to like that, and then change this guy to 2. So now you've created 2 users already. Right, so you created 2 users. What's the point of creating these users? Now you could save this user to database. You could save the second user to database as well, right? Or you could print these users on the screen. Like you print these 2 users on the screen for real. Yep, yeah, you could do that. If we put this guy to console.print, it's gonna print them out like that. So this is like the class and the object, correct? And then how to use the objects themselves, right? And one more thing that I should point out to you is the class. Basically, what is the class member? So these guys here that I told you, these are properties, right? They're also referred to as class members of this class. And this method is also referred to members of this class members. Okay. So that is that. Just take your time, go through this video, pause it, take a look at what I did. I started with creating a class, user class. I came into this class, I added these properties. Go ahead, add these properties on your own, add this method, and then come here, create the first user object. And once you use the new keyword on a class like this, you've created an object. Now you have to access those object members or object properties. Assign the values to them, assign values to them. Just for assigning values, just for purpose of test playing or practicing, you can assign these values. And yeah, that's that. Okay. Alright, please subscribe to my channel. Let's proceed to the next topic, which will be so I would like to discuss a few things here. I would like to discuss from this point. Let's go a little bit deeper, just a little bit deeper, and let's discuss what a constructor is. But first of all, before we do that, let me just make sure that I copy this guy out of here. So I'm doing this because I need to keep track of what I've taught, the topics that I've taught. It reminds me when I take a look back at these notes remind me the topics that I've taught. So classes and objects. So much space. Okay, so that's that, classes and objects. I think I need to also bring this guy here. Alright, so the next phase that I'll be teaching you is constructors. Now, we are gradually coming to the business side of things, and the word constructors, I'm going to take away this guy here, and let's start from fresh stuff. Okay. So, what is a constructor? A constructor is a special method that takes the name exactly as it takes the name of the class. So it's the same thing. What happened? Yes, I want to save you. Okay, so this is a class. All right. We need to make a constructor of this class. A constructor is a method that takes exactly the name of the class. So if you look at this is a method, right? You see, this is a method, but it is not the name of the class, so this cannot be a constructor. To have a constructor, it has to take the name of the class. So first of all, that's one definition of a constructor. It has a few other points, but this is the first one. So let's make that public. Okay, the name of the class is user. And then that is it. This is a constructor. Right, this is a constructor. It has the name of the class, and that's all it has, just public, the name of the constructor. That's it. There's no return type. There's no return type at all. Like, it doesn't have a return type, it doesn't have a void, it doesn't have anything. Just public, name of the class, constructor is created. Okay? If you do not create a constructor for your class, C# engine internally will create a constructor for you while it's running, the default constructor for you while it's running background. If you don't create a constructor, so it's not going to create it here, but it's just going to create it at the background while it's running. But if you do create a constructor and you want to create a constructor, there's a short form, type CTOR. Once you type that, take note of this note here, tab twice. So you just do tab twice, and then it's going to start for you once you type CTOR. Alright, so that is a constructor. So why do we need a constructor in a class? Why? Like, is it important? Yes, it is nice, because a constructor can help you initialize stuff, right? It can help you initialize things. You don't even need to worry about anything, but you just have you're just gonna have it stuff initialized for you, and that's why we have constructors. I'm looking for a good example so I can initialize something real quick, so that you could see that the constructor is something good. Okay, for example, right, remember when we did the last one, classes and all of that, we created this class and we went over here to assign the values here. Well, that was a little bit messy and dirty, right? So just so long and so many things written here. Why don't you just assign those values in the class here, right? That would be nice. Assign the values in the class here and you will have it created. Right? A constructor can have parameters. A constructor may not have parameters. So let's start with a constructor with that parameter. This is a constructor with that parameter. But let's say I want to assign the values here in this constructor. So we already have this user here, so I'm going to just assign the value of the user in the constructor. User 1, username. Okay, there's a keyword called this, right? So this means you're referring to the value in this class. Okay, I'm just showing you that for an example. You don't have to do it, it doesn't matter. For example, I could just do this right now, it doesn't mean anything. ABC and then password. That's the password. Alright, so we have this guy here now, right? When we come in here, all we need to do is user, new user, and then I'm going to put a breakpoint here. You're going to see that we do not need to initialize, we don't need to pass the values of this user in here anymore, because we already passed it there, and it's just clean, right? Then you see how clean it is. But this is parameterless, no parameter constructor. So some of the constructor you will have to pass a parameter, and I'm going to show you the parameter constructor very, very soon. So I'm going to run it just to show you that it's cleaner, right? You got the values here. So you inspect it here, you're going to see the values. Why? Because you've set the values in the constructor. That is what constructor is. Constructor is help to initialize and set the values of a class, properties of a class. So if I go here, you're going to see, look at the values here, right? You already have the values in here. I user ID1, like that. So this is the benefit of a constructor, right? It helps to organize the code. It helps to make sure that we can initialize values and set the values and all of that. This is a parameterless constructor. But let's go and do parameterized constructor. And then we can go from there. Alright. I'm going to show you parameterized constructor very, very soon. So let's go here now and let's pass in. Basically, let's just make sure that this username, user ID and password is set from a different class. It's being passed to us from a different class. The values are passed to us from a different class. So we're gonna do int user ID. That way, we can create multiple objects and pass multiple values. String username, and then string password. Okay, in this case now, this is where this is important. That way to differentiate between this one and this one and the one that is passed in the constructor. That's why this now can help you differentiate that, because this one refers to the one in the class. This refers to this one in the class, and then this one without this refers to the one in the constructor. That's why at this point it's better to use the this keyword now. So now you can differentiate which one is which. Right. So right now we have that set right there as a constructor with a parameterized constructor. Once we do this, the other one over there is going to fail because it doesn't have no constructor. There's no constructor with that. All the constructor will have, the constructor that we have here has parameters. So this one here will show an error. See? There we have an error here. There is no argument given that corresponds to the required formal parameter, user ID, blah, blah, blah. It is telling you that, hey, you need to pass some constructor here, right? So for here, let's just pass in the value. So look, if you hover over this, you're going to see it needs a user ID, comma, it needs a username, comma, it needs a password. So you're going to pass that in. So I'm going to pass user ID 1. I'm going to pass user ID, let's say first user as a user ID, and then a password of, because it's the first one, let's just pass password of ADA, right? And then let's create another one again. So right now we create multiple multiple users. But this time around, you just call this user 2, and then call this 2, and then call this second user, and then call this BBB. But let's do another one again, third one. We just have like 3. We create 3 instances of a user, so 3 users now with just one class. This is why they say object-oriented programming, because with one class I can create 3 objects. Okay, so this is the third user. Let me just call this one third user. I'll just call this one C. Alright, so that's that. Okay. Now what do I want to do with this user? Wouldn't it be nice to actually add up all these users into a list, into one list, instead of having them in 3 different places? Just add them up in a list. So I'm going to introduce the concept of list. Okay, so what is a list? A list is just like you have a list when you're going to the market, you're going to the groceries to buy something. You have items in that list, right? So this is the same thing. We're going to have a list that has items, and these items are going to be user items, list of users, and it's going to be user 2. Actually, let's do user 1 here. So just so we kind of, yeah, okay. So it's going to be user 1, user 2, user 3 in the list. How do you do a list in C#? Simple. Just list, and then you pass the user of the list. So look at it. List of users. So it's like you're going to buy a list of groceries, right? Well, we have list of users like that. Okay, with this coily brace, rectangular braces, like arrow braces, arrow braces like that. Put the user inside of there. This is the instance of that user. So with that, you can see that the user has a S, capital letter S in there, like not capital letter. It's like a plural users now because it's multiple users and all of that. So how do you insert values into the list, into the bucket list? So this is like a bucket list. You want to put each user inside this bucket. You want to put them inside a list. So for a list, all you need to do is look at it there. It's already showing users.add. Then you pass your user. So I'm going to pass the first user. I'm going to do users.add again. I'm going to pass the second user. Right, user.add, open close bracket, pass the user, and then user.add, open close, pass the third user. Okay. Now, what is the benefit of this? Why do we need to use this? Why do we need to have it on a list? First of all, I want to run it and show you that right now, once we add it to the list, you're going to see that this list will be implemented into 1, 2, 3, 4. I mean, we have only 3, right? So let's just run it and let's just run it and come up to this point, right? So I can show you what it is. Okay, so we're here. Alright, so we've created this first and second user. Let's create the third user. Let's create it. Now we're creating a list. Remember, the list is also like a list object, right? You're creating an object of user, but it's a list. So that's why you see like a new list object. So it's a list object, user objects, list of user object, new list of user object. Okay, so that's why you see new in there because you're creating an object. So you're going to add the first one. Remember, this list now is count is 0. Look at that, count is 0. Also look at inspect here too. Once I go to the first line, you're going to see the count will be 1. So the count now is 1. If you inspect it now, if you like inspecting, it means come here, click on this little arrow, and then you're going to see the count there. Count 0 is that one, and you're going to see the second count 2, count 3. So when you come in here, you have 3. Remember, the array index usually starts from 0, so you can see that it's 0, 1, 2, but there are 3 items in there. This item here of one object, user object, that is there of second user object, and then that is there of third user object. So now you see that you have a list of objects in here, right? Which is a way of me introducing to a list. Okay, so this is how to have multiple objects into one bucket, right? But how would you so when you have this list now, how would you get values from this list? Well, it's something like when I taught you arrays, you could do things like users, and then you could do that, and then put 0 to get the first index. Okay, so this means that you're getting your first user. First user equal to that. So right, if we run this now again, you're going to see that we're going to get our first user in there. Run this. So we have our first user in here, and you're going to see that we have the first one, user ID 1, password AAA, first user in here. That's how you can get your user. But most of the times when you have a list, you don't just necessarily have to, have to get only one user. You usually get things like, you check first of all if the list user dot count is greater than 0. So this is now a little bit of programming I'm coming in, so I hope you kind of understand. If the count is greater than 0, so truly the count is greater than 0, so that means there is content in this place. If you don't want to do this, you could do this dot any. This will return you a boolean, a true or false. If there is any use, like any, it means that if there's any user inside of it. So users.any means users.any user inside of it, which means, oh yeah, there's users inside of it or not. If there's no, if this is true, then it will come inside of here, right? So if there's any user, we want to go through that user. Remember, I taught you for loop and I taught you for each loop. It's up to your preference, whichever you want to use at this point, but let's use for each just because it's cleaner, right? You could do users now, like that, and then put user here, remove the S because it's users, and then this is one item, okay? And then you could print out console.print, console.writeLine, console.writeLine, sorry, console.writeLine. Let's print out the username, okay? Just the username. So we do username. Okay. So this will print out everything on this list for us, right? So what do we expect? We expect to see first name, second name, third user, sorry. Right? Let's run it and let's just see if it's printed out for us. Okay, it's first name, second name, and third name. Right. So so that's it. Okay, that was a little bit is constructor and list. Okay, I think I need to change this guy to constructor and list. That way that way I kind of know that I covered constructor and I also covered the list for you, and then I also helped you kind of know how to check for conditions if something is in there or not, and then also how to use for each again. All right, so that was that, and this time around I want to teach you a few things. I would like to teach you I'd like to teach you the 4 pillars of object-oriented programming, which is inheritance, polymorphism, abstraction, and interface. These are the 4 pillars of object-oriented programming, and after that we will be taking a break, and that is almost everything that you need to know. Yeah, that's almost everything you need to know on C#, but we'll be taking a break from there. If I get anything else that I didn't cover, I will just come over and record again, but we're going to cover the fundamentals of object-oriented programming, 4 pillars of object-oriented programming. Okay, so for right now, let me just take a screenshot of these real quick. Alright, so that being said, let's clean up this guy again. So, this here is the core pillars of OOPS, object-oriented programming, right? Usually called OOPS. Alright, so when they say the core pillars, the fundamentals, so these are the pieces that actually make it blend, or make it solidify together. Along the line, I think we've covered 3 of them already without you knowing, but I just want to point them out right now so that we will know about them. The first one here is polymorphism. And the second one is abstraction. Oh, let's do encapsulation. Second one is encapsulation. The third one is abstraction. And the last one here is inheritance. Now this one we haven't touched at all, so that's why I'm leaving it for the last. We haven't touched it at all. But all these other lines, we've touched them a little bit without you knowing, so we could try to explain them one after the other. Alright, so what is polymorphism? Polymorphism just refers to the act of multiple existing in different forms. Okay, so something existing in different forms is called polymorphism, right? polymorphism. This is not polymorphism. What am I spelling? Polymorphism is not that. This is polymorphism. Yeah. Okay, so polymorphism means something existing in multiple forms. In this case, your method will exist in multiple forms. And we've actually touched on polymorphism a little bit by doing method overloading. Remember when we did method overloading and method overriding? And we haven't done method overriding yet, but we've done method overloading a little bit. And that is a form of polymorphism when you have a method that exists in several forms. It is called method overloading. That is part of polymorphism. Okay, so let's go back to our user class. In the user class here, we could do get username. That's get username, right? So let's do another get username again to overload this get username method as an example of polymorphism. So get username is complaining because there's no overload here. It wants to overload it. Get username by username and then by user ID as well. So once we do this, this method is overloaded, and this is a form of polymorphism already. Okay. Method overriding is another form of polymorphism. It means that this method would be overridden in a different class, right? So if we come here and we do things like I'm just thinking an example I can give, for example, method overriding. So if we come here and we're going to try to override this class, okay? But for overriding a method, you will have to set that method as a visual, right? So it's not like, so you're going to do virtual, okay, and then forget about, okay, so that's that, and then we pass in nothing. How about passing nothing? Okay. And how about we say right now we're going to return, instead of returning that, we're going to return this .username. Right? Okay. So for you to override a method, for you to override the method will need to be declared as visual, okay? And then in the calling function, in the calling method, you will have to declare that you have to now override it with the word override, right? The word override. First off, you have to do this inherit users. I don't want to mess with this class. Let's leave this class alone, because this is where we come to do our printing and all of that. Let us create a different class right here. Okay, so let's create another class in here, just to public class. name, just call it demo class. Demo class, right? Inside here, let's inherit the user class. Now I've mentioned the word inheritance right now, so okay, doesn't like something in there, so why doesn't it like it? There is no argument given that corresponds to the required. Let's see. Oh, okay. So, right here, we have to overwrite that method that we have in here to use it. So any method that's going to use this guy will have to override it, right? So if I copy this guy over, I'm going to just override it here in this class. It's going to be called override here. Override. Right? So now we can override this class to pass anything here. Instead of returning this guy, we're going to change implementation. So for method override, the calling class that is overriding it can change implementation. Change everything. Whatever thing that is being implemented before doesn't matter. Right now, we can change it now to return this is the overrided value. Override value. Override value. Right? This is the override value. This is method has changed right now. And then when we come in here, so we'll create an instance of that class and we'll do demo dot. We need to get our get users. Okay. Get user. Well, this guy still is asking for something here. Because the constructor, we had a constructor there, so it's just asking for the constructor value. Password is, let's just put random password here. And then when we come here, you're going to see that the value that will be passed here, this result value that will pass here, will not be this name A. So remember, this name A is what is going to be passed into this constructor in here, and then this will be passed into this guy here, because we are setting it here. But that's not going to be what's going to be passed in here because we changed the constructor. This one here is what is going to be passed because we overriding what is supposed to be passed. So we are returning get user is going to be returning this guy. So let's take a look at what the answer would be before we go ahead and do anything else. You could see what is being returned here. This is the override value. So this is the one that is being returned here. It's an override, and that is what is being returned. So that is good for us. For method overloading and polymorphism has two forms actually. Let's make sure we know that overloading method overloading So that's two forms of polymorphism, and I've just demonstrated the two forms in this one here. Encapsulation is very easy. Encapsulation means exposing. Basically, you determine what the user is supposed to see. Like, that is encapsulation. You determine what the user is supposed to see based on the data that you have. Okay, so for example, we could come here to the user class and we determine that, hey, we don't want anybody to see this method here. I don't want anybody seeing this method, so I'm going to put it as private. And also I don't want anybody seeing this method, so I'm going to put it as private right here, so nobody can see these methods. So this is encapsulating this method only to this class. Nobody else can see. If we want someone to see, we can put it back to public, so that when we come here, to this place and we do users, and we do like a user, let's see, because this demo class is inheriting that. You see the demo, we have it too. And that will take me to the next point, inheritance, right? So demo has get user without parameter, because we commented out the ones with parameters, and we told them private, but it has access to this one without the parameter, right? Get user, right? And then it has everything else in there. So that is encapsulation, right? What about abstraction? Abstraction means taking all the implementation. So like this implementation, this thing here, we could hide it. We could put it in a different method and just make sure that it's hidden. And the implementation, like this guy here, we're implementing something else. Remember when we took this assigning to this guy, these guys that have been assigned here. Remember when there was one class that we had, and we actually were assigning these values over here, right here, all of them, assign them all of them, line by line, user 1, user 2, assign the values here. But then we abstracted all of them and put them inside in this constructor, and then we're using this guy right there, right? So that now at this point is abstraction. The abstracting it, only showing like people don't need to see you assigning all of them one by one. But you could just pass it like this, just one like that, just pass it like that. People don't need to see what is going on behind the scenes. Right here, this is behind the scenes. People don't need to see what is going on behind the scenes. That is abstraction. Okay, that is abstraction. Now the big one, inheritance. I haven't really covered inheritance, but I'll cover it right here. So basically, this is inheritance right here, happening in this class right here. So inheritance is, you have a parent class and you have a child class. The parent class has everything, just like in a day-to-day life. Your father, your mother, your parents have all the things, the buildings and everything. Whatever your parents have, you also have them too. Okay, so what is the key to accessing those things? Is because you are their child. Okay, so in this case, the user class is the parent class, and the user class has all these guys here, all of these guys. It has all of these guys, right? So for right now, I'm going to take this guy back to public so that we can see them too. Public. Alright, so all these guys, any class that inherits from this class will definitely be getting all of these guys too. So This is the inheritance. Basically, you are having access to everything that your father has. So this is the parent class and this is the child class. If you inherit from the child class, you're going to have, from the parent class, the child class will have everything. That is why you will see that when we do this new demo, and if I come here and I do demo, this demo class dot, it has the username, it has the get username, the first one with 2 parameters. It has a user ID. It has a get username again with no parameter. It has a password, and it has basically it has all of these things here. So this is inheritance. You inherit from the people that, I mean, you inherit from your parent class. So this is the parent class, and this is the demo class, and the child class. That is that. Alright, so these are the core pillars of object-oriented programming, and this right now is the fundamentals of C# and fundamentals of object-oriented programming that I wanted to teach you guys. Make sure that you guys kind of have an idea what C# is and what is the programming language all about. I hope you've enjoyed this. I have just one more to show you and I will be done. So basically there's something called enums. So with enums, you could, it's like enums is like a class too, but it just holds it's like a special class, right, that holds special constants, right? It just holds constants that are more like have the same so for example, you could have an enum that represents something, like for example your level. You have low, medium and high, and you want to always to use that to represent something, like something in later on. You could use enums, and usually enums are created in this way. Enum like that, and then you got to give the name of the enum, level, and then you just open curly braces, and inside of the enum you kind of write the levels, right? So low, comma, medium, comma, high. Right. So then when anybody wants to use anything here, the enums here, you can just do level. So you could just choose from the enum level, right? And then you just do enum.low. Or you could do level.medium as the medium level. That's it. This is enums, and then we can use this, to check to do a lot of things. Check if the level is low, check if the level is high, and use it to do like if something is equal to medium, then do something, stuff like that. So you could do all of that as well. But this is just to like show you like what enums are and what they are all about. So I'm going to stop right here. I believe that I tried the very best I could to cover most of the concepts of object-oriented programming and programming itself, methods and all of that we did here. We also covered method overloading, method overriding, encapsulation, arrays, list, switch, if, else, and all of those kind of conditional operators and all of that. I wish you the very best of your learning. Please practice this stuff. Now, when you've learned this thing now, you can now graduate to going to study application development, like web application development. Now, using C# now, you can go in and study web application development, or you can try to study automation testing because you now know the basics of C#, or you can study just building applications, mobile applications with C#, and just use this knowledge of C#. Please subscribe to my channel. Please, I beg you. Thank you very much. I appreciate your subscription, I appreciate your like, I appreciate your love. Thank you very much, I appreciate it. Thank you. Have a blessed day. Thank you.